So sorry, I'll do this sitting down. I don't want us to waste double lesson. So far, last time we did this, right? You have worksheet that has this kind of question. I believe some of you are ready to submit, but please later. Now, we want to use discriminants also in understanding the graph of a function. We did something last time. From your ax squared plus bx plus c equals to 0, or maybe not equal to 0, you can always get the vertex, right? The x at vertex. Using what? Anybody remember?
The root?
No, before the root. The x coordinate of the vertex, yes? Negative b over a is the x coordinate of the vertex. Without solving, because you have to solve to be able to add the two equations together, right? And divide by 2. But you don't have to do that. We demonstrated that the last time, that when you add those two roots together, it's as good as just doing minus b over 2a. Hello? Understand? Remember that? Okay. So, what this is trying to tell us is using discriminants to also understand graph of function. And this will lead us to positive definite and negative definite graphs or quadratic functions. One sec, please. Okay, drink. No, you're not drinking. Get back. Everyone is present now. All the babies are present. No purple. Yeah, finished. I have to go there again. Hopefully I can take everything they have again. Now, what might be new to many of us is this b squared minus 4ac. We call it the discriminant. It's not that hot here. We are colder, so I can survive this. In your quadratic function, ax squared plus bx plus c, Joey, can we see this part? Please make sure of that.
Sorry.
I could just zoom out, or tell Carolina what to do.
It's okay.
Or just zoom out so we can cover both. I won't go beyond here, so you don't have to keep going.
No, it's fine.
All right. By quadratic formula, x is equal to minus b plus or minus square root of b squared minus 4ac over 2a, right? Yes. This expression under the square root is called the discriminant. I'll tell you why they call it discriminant. Well, this is a joke. But that's the way I understood. Because while English is my country's official language, it's not my mother tongue. So like many of you, I struggle to understand some things because they are written in English. But if I can break it down, then I can do better in my exam. Do you understand? It's like I'm teaching something and I can tell you that thing in Chinese, then you can communicate back to me in English because now you understand it. Okay? The word discriminants sound like something that we don't normally want to talk about, something negative. What is that? Discrimination. And when we talk about discrimination, you are treating people not so equally, right? Or you are trying to say something that normally you shouldn't have even said. Okay? For example, I come to class, or maybe somebody comes to class and give us a form from the government, and there's the word race in it. Like, oh, why do you have to know my race to give me whatever the government is bringing? Then everybody, oh, you have a problem with Asians? You have a problem with Africans? Then everybody start asking questions. Because we see that as a discrimination. Do you understand that? You see, this guy, D, equals to b squared minus 4ac, discriminates a lot. Against who? Against the roots of the equation. The root of the equation means the answer we will get, the x1 and x2. x1 and x2 see themselves as humans. But this guy often reminds them, oh, you are a European. You both, you are Asians. You both, oh, you are black people. But they actually don't care until this guy came on board and started telling them the differences between them. Am I making sense? I'm telling you this kind of analogy so you remember what I'm about to tell you. Minus b plus or minus root d, because I said d is equal to this, right? Over 2a, right?
Yeah.
If this d is equal to 0, whether you do plus 0 or minus 0, does it matter? Talk to me, please.
No.
So they will be the same eventually, right?
Yeah.
Then you're supposed to get x1 and x2.
Yeah.
If this d is equal to 0, it doesn't matter whether you do minus b plus 0 or minus b minus 0, so x1 and x2 will be the same, right? In that case, we say the roots are equal. The root never said, is there a battery problem?
No, there is no.
Everything is good?
Yes.
The roots never complain. They never see themselves as equal roots, complex roots, whatever roots. They are happy as roots until Mr. This b squared minus 4ac came around. That's why it's called a discriminant. It's the guy that discriminates. Do you understand that?
Yeah.
Then Mr. D came and said, oh, if I can make this greater than 0, you guys will be unequal. And it's true. The lowest number that can be greater than 0 is 1, isn't it? Minus b plus 1, minus b minus 1, would they be the same or different? So if they are different, divided by 2a will also be different, right?
Yeah.
So when d is greater than 0, x1 will never be equal to x2. So they will be different. We use the word distinct for that. Okay? But of course, like every other number, d can only be 3 things in life. Either greater than 0, equal to 0, or what? Or less than 0. So d has used its power to be 0 here. Its power to be greater than 0 here. The only power left is when d is less than 0. Isn't it? When d is less than 0, if you are not HL student, you get stuck. You cannot find the square root.
Yeah.
Square root of minus 4. That's a problem. Do you understand that? Then you say, oh, you guys are too complicated for my liking. How can you say square root of minus 4? There was 16 there, you never picked that. Accusing b squared minus 4ac. There is 9, easy to calculate, you never picked that. Why do you have to be negative? You guys are too complex. So when this less than 0 is classifying x1 and x2 as complex roots. Am I making sense?
Yes.
So you remember, or if you try to understand these jokes that I'm trying to tell you, x1 and x2 are cool with just seeing themselves as roots of quadratic equation with no attachments. But the only guy that messed it up, so they start seeing themselves as different. Oh, we x1 and x2 for this equation, we are equal roots. Then there's another x1 and x2 for another equation, oh, we are complex roots. So see the equation as parents, x1 and x2 as the children. It's like every child seeing themselves as child. Then suddenly you talk to 2 babies and say, oh, your parents are so poor. But they never thought of that until you brought that point out. Then you are the problem. That is how I learned more about discriminant back in the days. I tried to think of this analogy. The guy that discriminates. Am I making sense? Why did I mention this? Because that is the basis of what we are about to do. If they are equal roots, it means x1 and x2 are the same. What you will notice on the graph is that it's just going to touch. If they have distinct roots, it's going to cross. Because remember, where the curve meets x-axis is the root of the equation. If there are two different roots, this is what you expect to see. If there is only one root, which means the root is repeated, this is what you will see. And if the root is complex, it means it will never touch. So if this is your x and y axis, maybe you have something like this, or you have something like this. It will never touch. Am I making sense?
Yeah.
This is the idea that we are talking about today. Okay, so if I go through with your book now, you should be able to understand. But this is what is responsible, the different values of discriminants. Okay?
Yeah.
So if I need you to classify the nature of roots, when I say the nature of roots, maybe classify the children. Okay? Classify these children. Oh, these children are from wealthy family. You are attacking their family, but through the children. Do you understand that? Oh, these roots are distinct roots. Well, the root never produced themselves. It was based on the quadratic equation. Am I making sense now? So if you want to classify equations, you use the discriminant and you focus on the roots. This quadratic equation has complex roots. This quadratic equation has equal roots. This quadratic equation has distinct roots. Okay, so normally we say these are the three categories. I'll give you a short note over there to summarize everything. Okay? Where's this body stuff? Somebody stole it. It's you.
Hey,
Stole it.
I'm sorry. I'll pay you back.
So let's talk about the discriminants in a summarized note here. Then we'll be able to, so that you can always refer to that later. Okay? So let's write today's date. Thank you, Miss Joey. You can just let it focus here and come back. Okay. Today is 9, yes? Yes or yes?
Yes.
Yeah. Okay. Yeah, I'm not giving you any option. Ada is wondering, wait, why did you have the question?
So I wanted to say yes.
So, nature of roots of ax squared plus bx plus c. Nature of root of quadratic. For any quadratic equation, ax squared plus bx plus c is equal to 0, where a cannot be 0, we know that x is equal to minus b plus or minus roots b squared minus 4ac everything over 2a. The expression, or should I say the term, b squared minus 4ac is called the discriminant of the equation. Which describes the nature of roots of the equation. Does this make sense? Let that discriminant be. Let the discriminant be d. Then the equation ax squared plus bx plus c is equal to 0 has, number 1, real and distinct. The word distinct means different. Roots. If d is greater than 0, real and equal roots. If d is equal to 0, complex roots if d is less than 0. That's what we've been talking about. Graphically, we can illustrate as follows. I will only put the x-axis. So this means d is greater than 0. This means d is equal to 0. Maximum or minimum. So here, this is the first one. For d greater than 0, this is what the graph looks like. So d is equal to 0. And for d less than 0. Is equal to 0, something like this. It's just going to touch this one, you know, something like this, or something like it never touches. Okay, this is the summary of everything we've been talking about. Ready? Yes. You can do it. So the next thing we will look at is the positive and negative definite quadratics. Not too tight, not too loose, so that it can be easily moved. Is it okay, Joey?
Yeah.
Oh,
here.
Yeah. Where's it going?
Oh, my bad.
So everybody, you understand the idea of discriminant, right? You see, without plotting the graph, you can know if it's going to cross, it's going to touch, or it is far away from the x-axis by just calculating the discriminant. Understand? I think we have one, I don't know, maybe it's illustration or example. Okay, it's just an illustration. You see? Look at the first one. The equation is this. Without plotting, you can just calculate this. This 16 tells you that's d greater than 0, right? It means there are two roots. It means it touches at 2 points. Touching at 2 points means it crosses. Do you understand that? So if I'm giving you maybe multiple choice part of maybe a test, for example, these are the simple questions I'll probably ask. Okay? Considering the quadratic function with this equation, which of the following is true? Oh, it crosses at 2 points. It touches at 1 point. It never touches the x-axis. None of the above. Do you understand that? Or I write an equation, ax squared plus bx plus c, and tell you discriminant is greater than 0. Which of this picture could represent the function? So it's not, I don't want you to learn or study the syllabus just by going through all the topics. You can solve the past question and that's it. I need you to understand what is really happening, the whys and the hows. Okay? So you can see different ones here. 16 greater than 0. The b squared minus 4 is greater than 0. Automatically it means it touches. Of course, it could have been the other way around. Okay? For the other one, it's equal to 0, oh, just 1 point. Alright? We are not concerned about what this is for now. Am I making sense? To get what this is, we talked about that the last time, which is by b minus b over 2a. Am I making sense now? Then for this one, negative 8, that means it never touch. Are you with me? But this is everything we have been talking about. If you look at your textbook, you will see the same thing. Now, here is another concept. Positive definite and negative definite. Hey, Miss Kadina. You alright? Positive definite quadratics. Now look at this. Look at the difference between these two. What do you notice? These two. One is what? One is maximum, one is minimum, yes? They never touch. What else?
One is concave upwards, the other is concave
One is concave up, one is concave down. You can observe so many things. But in terms of positive definite and negative definite, if your quadratic is always greater than 0 for any value of x that you substitute, it is a positive definite quadratic function. And you can only have that if you have something like this. Okay, I'll just use this. You can only have that if you have something like this. You can't have this and still positive definite. Because remember, it's coming from down. For every x you substitute, all your y's are greater than 0. So it will look like this. Okay? Only the minimum type of graph will give you that. Minimum means it's coming from positive, it's going to turn somewhere and go back to positive. Am I making sense? So when you see this, this is a positive definite quadratic. Think of it as a statement. Positive definite. Definitely positive. Do you understand? Oh, this is definitely going to be a positive value of y. No matter what I do, either substitute a value, it is positive. Kelly substitute a value, it is positive. Or you substitute a value, it is positive. Everybody substitute value, it is positive. Oh, this is so Mr. Daniel comes with his value. Mr. Daniel, this is definitely going to be positive too. Use that to remember. Okay? And try to sketch yourself if you forget what is the definition of positive definite. I can only have positive definite if I have my x-axis. Remember, x-axis is y is equal to 0. Hello?
Yeah.
If x-axis is y is equal to 0, you can only have that positive definite if everything is over here. There is no way something that is coming this way will give you that, because some of them will still be here. It will only be something that is up there. And your quadratic extends indefinitely. So don't tell me, oh, how about this one? It should extend indefinitely. We say for all r. If this is negative 1 million, what happens to negative 2 million? That means it's still going to come down. Am I making sense? So the only situation where you can have all positive is when you have something like this. And the only situation when you can have all negative is when you have something like this. So when I put x is equal to 2, the answer is negative y. When I put x is equal to 20, the answer is negative y. Remember, y is on this side. Am I making sense? Ryan? I need some acknowledgement, okay? Look at this. All these y's, these are positive y, negative y. There is nothing you can substitute on this line that can be linked to negative y. So any value is going to be definitely positive. This is a positive definite quadratic. Okay? How can you know it's a positive definite? It will be a minimum 1, right? When do you have minimum? When it's greater than 0. When do you have this situation? When it doesn't touch? When your discriminant is what? It's less than 0. That is why in both cases, your discriminant is less than 0. Joey, do you mind using Carolina's sit down so they can see it? Okay. And you can always turn that down so you can see the screen without actually standing. Yes. Does this make sense? Ryan, I'll go back again. We have this when A is less than 0. Do you agree? And this is when A is greater than 0. No. A is less than 0. Is that not? That tells you the direction, concave up or concave down. The second condition is that it never touches. The moment it touches, we say positive definite. It means it gives you y is equal to 0, right? 0 is not positive, 0 is not negative. So for it to be indeed positive, it means everything must be positive. Am I making sense? That is the reason for the second condition. And it will not touch the x-axis if this is what is happening. So these are the two conditions. When it is positive definite, know that both of them are discriminant less than 0. Okay? Positive definite when A is greater than 0. It's easy. Negative definite when A is less than 0. Am I making sense? So if you want to check if something is positive definite, you check two conditions. Since A is greater than 0 and you work out your discriminant, then you tell us, therefore, this must be positive definite. Hello?
Yeah.
Everyone is tired, including me. Let's check this out. Let's check this out. Maybe I'll play a song for Kelly and Rita and Hansen so they can dance and the sleep can fly away.
Since the discriminant tells us the number of real roots of a quadratic equation, it can quickly tell us the relationship between the graph of a quadratic and the x-axis. If it is positive, there are two distinct x-intercepts, so the graph cuts the x-axis twice. If it is 0, there is only one x-intercept, so the graph touches the x-axis. If it is negative, there are no x-intercepts, so the graph does not cut the x-axis. In part A, we use the coefficients to calculate the discriminant. We find it is minus 7, which is negative, so the graph does not cut the x-axis. The coefficient A is greater than 0, so the graph is concave up. The graph must therefore lie entirely above the x-axis. The quadratic is positive for all values of x, so we say the graph is positive definite. In part B, we again use the coefficients to calculate the discriminant. Simplifying, we find it is 33, which is positive. So the graph cuts the x-axis twice. The coefficient A is less than 0, so the graph is concave down. Since the graph cuts the x-axis, there are values of x where the quadratic is positive, and values of x where the quadratic is negative. The quadratic is therefore neither positive definite nor negative definite.
Okay? All good?
Yes.
So I will leave this on the screen. I want you to attempt, let's just attempt 1A. Or you have your computer, I'll send it to the WeChat. All right? So
Can I use my phone, my laptop?
yeah, use your phone, of course. I'm not going to be that strict with this class. Okay, let's write a. Okay, I'll send a screenshot of this. Please write about positive and negative definite, negative definite also in your notes with those pictures. Understand? And send sleepyhead. So write something about.